You've probably heard the term X-ray before. So what exactly are X-rays, and what are they used for? It was the German physicist Wilhelm Conrad Röntgen who first described this type of radiation, calling it X-radiation, which is where the modern term X-ray comes from. In 1901, Wilhelm Röntgen received the first Nobel Prize in Physics for his research. So what actually is an X-ray? Simply said, there are two types of radiation on our planet. Particle radiation, for instance neutron, alpha, or beta radiation, and wave radiation. Both visible light, that is light we can see, as well as X-rays are types of wave radiation. X-rays are a type of light ray, but with much shorter wavelengths that are outside the visible spectrum. X-rays have so much energy that they can break electron bonds, and in this way, alter matter itself. That's why they, along with alpha, beta, and gamma radiation, are types of ionizing radiation. In comparison to alpha, beta, and gamma radiation, X-rays do not occur as a result of radioactive decay, but rather are generated through a technical process that occurs in so-called X-ray tubes. Here, the electrons are accelerated by high voltage before smashing into an obstacle, which abruptly slows them down. From this sudden deceleration, energy in the form of X-rays is released. X-rays are used in many ways. For example, in industry, machine parts can be checked for cracks. Groceries can be checked for impurities. X-rays can also check the quality of car tires and the germination capacity of plant seeds. Perhaps the best known use is that of baggage security control machines at airports. They use X-rays to illuminate and investigate the baggage contents without needing to open them. Aside from its industrial use, X-rays are mostly used in medicine. X-rays can penetrate through all sorts of matter, some more easily than others. Skin, muscles, and organs are easily penetrated, but bones are not. Because of this, doctors can, for instance, recognize broken bones on X-ray scans. However, since X-rays are a type of ionizing radiation, they can damage our DNA. So before each scan, the benefits must be weighed up against the potential risks. Of particular importance is the so-called effective dose that occurs with each X-ray scan. This is a measurement of ionizing radiation that affects humans. It is measured in units of sievert or millisievert. With many screenings, patients receive only a small dose. For example, an X-ray at the dentist, or with a suspected broken bone, or via mammography. As a comparison, a flight from Frankfurt to New York and back exposes you to a dose of 0.1 millisieverts. In a computed tomography, or CT scan, many X-ray scans are combined, so that the radiation exposure is higher, particularly for sensitive tissue. A CT of the abdominal area can deliver a dose of up to 20 millisieverts. In Germany, around 135 million X-ray scans are made yearly, which is more than 1.5 per person each year. Compared to the rest of Europe, that's very high. If you live in Germany and want a better idea of your own personal radiation exposure, you can get an X-ray passport. In this document, doctors note down every medical screening you receive, so that no extra unnecessary scans are performed. If you'd like to find out more about radiation and radioactivity, take a look at some of our other videos.